Right. Good evening, everyone. Assalamu alaikum. Okay. So, in the last class, we started the biological processes in human bodies, blood circulatory system, right? So, the components of blood we have already discussed, I guess, correct? So, today we want to speak about the next part that is about the heart, the human heart. Okay? Yes, the human heart. Yeah. So, second part. Just work with these two. I will do it. Right. The human heart, right? So when we come for the blood circulatory system is basically made up of two major organs, right? What are the two major organs? One is the human heart, and the other one is the blood vessels, all right? So different types of blood vessels you have got. So blood vessels collectively connected with the heart, it works for the circulation, the circulatory system, all right? So heart is the major organ here. So here what are we going to learn? Some of the theories you have already learned in grade 9 also I'm going to recall it because definitely you can't remember. Okay. So you can't remember those theories. So we are going to recall with them and we are going to connect up with this. So fundamentally this part, the structure only, the functions only you should know here. But the structures are there in the previous syllabuses. So completely we are going to recall up with, right? So the human heart, when we take the human heart, it is just a muscular structure, none other than as the people say. So, right? So the heart is being denoted with, it is used to describe different sort of emotional structures, right? So heart is not something like that. Heart is just a blood pump. Fundamentally, it is just a blood pump, none other than a blood pump it does. Okay, only a blood pumping process it is working. All right. So when you come to this heart is made up of skeletal muscle tissue. Oh, sorry, cardiac muscle tissue. Cardiac muscles already we have learned in the previous lessons. Okay. Basic muscle tissue here is cardiac muscle tissue and blood, nervous. So those drugs are also connected together. That is how an organ is formed up. Right? Tissues together forms up into organ. So when you come to this heart, we can divide the heart into upper and lower chambers. So I'm going to give you a rough diagram. Usually in the questions, either this or this. One of these would be taken into the question. Okay, one of these would be taken into the questions. So upper chambers we name as the atrium or else auricle, while the lower chambers we name as ventricles. Atrium and ventricles. Okay. So this is my right side, this is my left side. Okay. So lateral inversion we are taking up. Okay. So this is the right side, this is the left side. So to the right side, upper chamber we name as right atrium. Right atrium. Left side upper chamber we name as left atrium. And right side lower chamber, lower room we name as right ventricle, and this is left ventricle. Accordingly, 4 chambers are there are 4 chambers, right? So all these chambers are connected and they have been spaced, divided, separated. So completely 4 chambers could be seen. So fundamentally, right side is mixed up with one type of blood, while the opposite blood is there in the left side. So what is this one type and opposite type? So this is based upon the content of the gas. If it is carbon dioxide or oxygen. Can you remember? Earlier, some of the lessons we learned, digestive system, respiratory system, excretory system, those functions should be also connected up here. Under respiration, we spoke about we inhale oxygen, we exhale carbon dioxide, and under cellular respiration, this oxygen should be taken towards the organs, oxygen supplied to organs, and carbon dioxide will be released out. Carbon dioxide will be released out. So this is connected to the heart directly. How is it? Now, when you go for this heart is connected with all the organs. So above the heart organs, I will name it as the upper organs. It is not a standard name, just we are taking, okay? Upper organs. Like head, the shoulders, upper arms and all included. And below the heart, all the organs, we're gonna name it as the lower organs. Right? Lower organs. Now, upper organs and lower organs, including all the cells, are connected with heart, and the connection is given by blood vessels. And blood vessels, when we are taking, there are 2 types of blood vessels, namely arteries and veins. So, if a blood vessel goes out from the heart to other organs, right? If the blood is carried out from heart to other organs, we name this as artery. And if the blood is carried from other organs back to heart, this is called vein. It is called a vein, right? So arteries and veins, these are the 2 major blood vessels. And these blood vessels are connected by blood capillaries as well. So small thin network of blood vessels, right? And here I'll name it as heart to other organs. Basically, fundamentally, what is the type of blood taken on? Oxygenated blood. I'll denote it in red color, right? Oxygenated blood. That means oxygen more containing, oxygen more concentrated blood. Other organs back to heart is taken as deoxygenated blood. That is denoted in blue color. Usually, these are the 2 colors we are using. But this would be exempted, that means opposite only at one place. When we are discussing, you can see that. Apart from that, all of the places oxygenated is given by red color, deoxygenated is given by blue color, and then deoxygenated is what given as vein. That means a vein carrying blood vessels as deoxygenated, artery is carrying oxygenated, like that is what given in throughout the body. Only one place it would be changed, but fine. Now, what actually happened? I'll start up with the carbon dioxide content part. So we already learned under cellular respiration. During cellular respiration, what happens is organs, in the organs and cells, producing energy would be taken place. Energy will be produced. Energy will be produced. So how the energy is produced? At the presence of oxygen. Aerobic respiration is it. So at the presence of oxygen means oxygen should be supplied. That is the inhaled oxygen. So remember, inhaled oxygen is the part I'm going to connect later. So I'm going to start now with the exhaled carbon dioxide, right? So now, oxygen, when it is provided for these lower organs and upper organs, all the cells, they produce energy. They produce energy. That is by cellular respiration. That means at the presence of oxygen, glucose will be broken down. When glucose is breaking down, it produces carbon dioxide, water, and energy. Carbon dioxide, water, and energy. This is what happens. Okay. So accordingly, carbon dioxide is produced. Now, this carbon dioxide is not something to be stored in our body. It has to be removed out. It has to be removed out. So what would be done? This carbon dioxide containing blood will be taken from all the organs to right atrium. So lower organs, deoxygenated blood is carried to right atrium, and this vein, it should be a vein, right? Should be a vein, right? Because deoxygenated blood. So other organs back to heart. This vein we name as inferior, right? Inferior vena cava, or else vena cava, right? Inferior vena cava we say, but we don't say vena cava. Okay, cava is something different, right? Cava or cava we say. Okay, so here inferior vena cava is the blood vessel which takes deoxygenated blood back to heart from lower organs. Likewise, upper organs are also producing this carbon dioxide, right? Upper organs are also producing carbon dioxide. So this carbon dioxide should be taken by another vena cava back to right atrium, and this is called superior vena cava. Right? So both of them are carrying deoxygenated blood. So you can see now deoxygenated blood is what taken towards this. Okay. So now both deoxygenated blood being filled up in right atrium. So right atrium being filled up with deoxygenated blood. Right? Now this deoxygenated blood, once it is filled up, it can't be sent back again, because this valve here the checkpoints, here the gates are only one way gates. Only one way. They can't be taken back. Right? Once it is entered on. Now, once the right atrium is filled up with this deoxygenated blood, this blood would be pushed down. Right? It will be pushed down. It will be squeezed down. That is because of, it is a muscle, right? There's a muscle. So you can see here, this is the right atrium. Okay. So this right atrium, once it is filled up, it would be pressed. It would be contracted. Because muscles can contract and relax. So when this muscle is contracted, blood would be pushed down. But here there is a valve. The valve is something like this way. Okay, this would be opening only downwards. Okay, so let's say this is the level. Only downward it opens, it cannot open upward. Because if it is opening upward, again the blood can flow backward. So the process won't be functioning properly. Only in inward it would be something like, imagine when you are going for the supermarkets and all, when you are going entering part, entry exit, two parts are there, right? Two ports are there. So there would be a gate, only one side you can go, the other side you can't. So only one entry gates are there. So this is a valve we see, and the valve between this right atrium and right ventricle. Between the right atrium and right ventricle, to cross this, we name it as tricuspid valve. What valve it is? Tricuspid valve. Okay, tricuspid. There are two cuspid valves. Right side it is tricuspid valve. Tricuspid valve. So across the tricuspid valve, now what is the blood here? Deoxygenated blood. Blue color. So I'll just mark it as blue color blood. Okay, so this blue color blood is what passing down. So again, blue color blood is there. Blue color blood in the sense that is not really blue color. We denote it as deoxygenated blood. Now this blood, once the right ventricle is filled up, again the right ventricle will be pushed. It would be pressed, contracted. Now that blood would be taken towards the lungs. So let me mark the lungs here somewhere. Right? Two lungs you got, right lung and the left lung. Okay. Now to the lung, this blood, the oxygenated blood should be taken. So who takes this blood? There is an artery. Now get the way. I said this is common everywhere in the body, but one place it is taken. Means artery in red color, vein in blue color. Because artery carries oxygenated, vein carries deoxygenated. This is the common case. But only here that gonna change. You can see here, right atrium, right ventricle is there. From the right ventricle, blood is taken to pulmonary artery. Why artery? From heart to other organ. From heart to lung. That means artery. Okay. But artery should be red color, but here the artery is blue color. Pulmonary arteries are given in blue color. Why? Because still not oxygenated. It is taking what is the blood does it take? It takes deoxygenated. Okay. So there are two arteries, two pulmonary arteries. So these arteries are called right and left pulmonary arteries. Right and left pulmonary arteries. Right to the right lung, left to the left lung. So you see now, pulmonary arteries carry, I'm showing in the arrowheads, deoxygenated blood towards the lungs, So these are the lungs, both the lungs. Okay. Right. Now, here too there should be a gate, right? So it is something like when you want to give an entry for someone, there should be an entry point. So here too there is an entry point. Here too there is a valve. So this valve we name as a semilunar valve. What valve it is? Semilunar valve. Alright. So this semilunar valve specifically we are giving a name pulmonary semilunar valve. What is the word? Pulmonary semilunar valve. Right? Fine. Now after that, now the blood goes to lungs, right? What is the blood? So out what we took now deoxygenated blood. That means carbon dioxide containing blood. Oxygen not containing. Simple idea. Oxygen not containing, carbon dioxide containing blood. Now the blood comes to the lungs. We already learned that lung is the place to purify air. Now it takes carbon dioxide. Okay, lung takes carbon dioxide from blood. That is the carbon dioxide released out, exhaled out. And the inhaled oxygen is there. That inhaled oxygen is taken to lungs, right? That inhaled oxygen is what now given back to heart. Given back to heart. So the red color we denote now. It comes to like left atrium. And there are 4 pulmonary veins. How many pulmonary veins are there? 4 pulmonary veins. So we name here as pulmonary veins. And there are 4 pulmonary veins. 2 to right, 2 to left, like 4 pulmonary veins are there. In your diagram, you can see here there are 2 and here there are 2. Both of them are connecting to left atrium. Okay, left atrium. So you can see here, once this oxygen is supplied, so oxygen taken by the lungs would be given to the blood. Now that oxygenated blood is what taken towards left atrium. So left atrium is being filled with oxygenated blood. What blood it is there now? Oxygenated blood, right? Oxygenated. Oxygenated blood, once it is filled up, it should be transferred down to left ventricle. Left ventricle. So here too there is a valve now. Here too there is a valve to control in between the left atrium and left ventricle. How do we name this valve? We name it as bicuspid valve. What valve it is? Bicuspid valve. So you can see here, tricuspid and bicuspid valves are there. Alright. So now across this valve, now the blood, deoxygenated blood is being filled to the left ventricle. Once the left ventricle is filled up, that the blood should be sent throughout the body. So it is taken towards the larger blood vessel. And this is the blood vessel sending blood throughout all the organs, which we name as aorta. Or else we term it as systemic artery. Systemic artery. Actually, though we take into the side here, this is the blood vessel connected up like a big pump here. Can you see? Like a big pump, it goes on. So that is aorta, systemic artery. So the systemic artery is connected to left ventricle. It takes the blood, oxygenated blood throughout the body. And it provides that oxygenated blood throughout the body for all the body organs. And here too, there is a valve. This valve is what valve? Semilunar valve. And here it is pulmonary semilunar valve. This one. And here it is aortic semilunar valve. Semilunar means we say half of the moon, that shape, crescent shape. So semilunar valve. So accordingly, 2 types of valves are there: cuspid valves and semilunar valves. So you remember right side right side tricuspid, left side bicuspid. So that is how the valves are going on. Clear? So accordingly, you see this is the whole process showing you how the blood is transferred. Fundamentally, you can observe now left side of the heart consists of blue color blood in the sense deoxygenated blood. So whomsoever connected to the right atrium, right ventricle, right side of the heart should be carrying deoxygenated blood. So you can see superior vena cava, inferior vena cava, deoxygenated. Pulmonary artery, deoxygenated. Okay. And then left side of the heart is comprising with red color. Red color means oxygenated blood. So whomsoever connecting in the left side of the heart should be carrying oxygenated. Accordingly, you can see pulmonary veins coming to left atrium should be oxygenated blood. Aorta goes out, so aorta should be containing oxygenated. So here, this process when we are taking, it is giving you two ideas actually. Two ideas means you can observe when blood is carried throughout the body. Throughout the body means lower organs to heart, again to lower heart. Or else upper organs to heart, again upper heart. So once when it is carried throughout the body, how many times it enters the heart? 2 times. Why 2 times? Lower organs to right atrium, right ventricle. It leaves right ventricle and comes to lung. Again left atrium, left ventricle, it leaves. So twice it enters the heart. So because of this, we name this circulation as double blood circulation. What blood circulation? Double blood circulation. So why double blood circulation? Because 2 types of circulation are happening here. Right? 2 types of circulation. What are the 2 types of circulation? Number 1 is systemic circulation. Systemic circulation means from heart to all other organs. From heart to all other organs. That means, you see, aorta takes out the blood, oxygenated blood, provides for upper and lower organs, and again deoxygenated blood is taken back to right atrium by vena cava. So this is systemic circulation. So I'll mark it as systemic circulation. And the next one is in between the heart and the lungs. Once from right ventricle to lungs and again from lung to left atrium. So this is called pulmonary circulation. Pulmonary circulation. So this combination or the product of systemic and pulmonary is also called as double blood circulation. And here, during the systemic circulation, who is pumping out blood? Who is pumping out blood? Left ventricle. So left ventricle pumps out blood. So remember, during systemic circulation, who is the blood pump? Blood pump is left ventricle. Left ventricle into aorta. Okay. And during pulmonary circulation, who is pumping out blood? Right ventricle. So right ventricle into whom? Right ventricle into pulmonary artery. Pulmonary artery. So you see, left ventricle to all body organs and back to heart, that is systemic. Right ventricle to pulmonary artery to lungs and back to left atrium, that is pulmonary circulation. So if I want to connect that also, left ventricle back to right atrium. Right atrium. In between that organs are there. And they what happen? Right ventricle to lungs and then again to left atrium. So this is what you term as double blood circulation. Is that clear? Totally clear about that? Okay. So especially here, you should know the structure, the parts of the heart as well as wherever they are connected. Okay. Anyhow, those stuffs you have already learned in grade 9. Okay. But yet those theories are also included in your tune. It is because of giving point wise. In an organized way, all the points are given. So any MCQs come, you have the answer on the tip. Any answers. Okay. So however they ask you the question related to the word deoxygenated, oxygenated, artery, veins, whatever, all the points would be included within the next part. Did you understand? Clear about that? So have a look on the tube now. process of blood circulation. We'll read there. Blood circulation is a major process occurs in human body. The transportation of essential substances to the living cells as well as waste substances out of them is carried out by blood. The system in which the role of transport function carried out in the body is the blood circulatory system. So the human heart is given completely. And the heart has four chambers. The upper chambers are called atria and the lower chambers are called ventricles. So what are the four chambers now? Can you tell me? We'll write there. Right atrium, right ventricle. You can write. Right atrium, right ventricle. Left atrium, left ventricle. Left atrium, left ventricle. Right atrium, right ventricle. Left atrium, left ventricle. Okay. What is next? Could you find out the word? What comes there? Tricuspid valve and bicuspid. But how do we write? Right? We'll write like this. Bicuspid valve is in between the left atrium and left ventricle. Bicuspid valve is in between the left atrium and left ventricle. Tricuspid valve is in between the right atrium and right ventricle. Right atrium and right ventricle. Right atrium and right ventricle. Okay. There are two main arteries connected to the ventricles. What are they? I can say there. Aorta starts from whom? Left ventricle. And pulmonary starts from right ventricle. Aorta also we say, right? Aorta starts from the left ventricle. Pulmonary artery starts from the right ventricle. Pulmonary artery starts from the right ventricle. What's next? There are semilunar valves at the starting points of the main arteries. What are the valves? Aortic semilunar valve is at the starting point of aorta. Pulmonary semilunar valve at the starting point of pulmonary artery. Okay. So the main veins connected to the atria. What are the main veins? Superior inferior vena cava connected to right atrium. Left and right pulmonary artery, pulmonary veins connected to left atrium. There it is. right? Fine. So we'll take the writing book. Please note this down. With the diagram, we can use two colors, especially the red and blue color. Use okay. That is to denote the deoxygenated and oxygenated blood separate. Right, done? Done? Right. Have a look on the next one. Arteries, veins, and all. Right. I'll send the pic. Go to the next page on YouTube. Next page. The following page. Yeah, page number 8. 8, sorry. Page number 5. At the bottom of the page number 5, there are 4 boxes given, right? Try to fill it up. The first box says the pulmonary artery which starts from the right ventricle of heart transports blood to lungs. What is the type of blood? You can write inside. Deoxygenated blood. What's the type of blood? Deoxygenated blood. Right. Second, aorta, which starts from the left ventricle of a heart, transports blood to the other organs. What is it? Oxygenated blood. What's next? Pulmonary veins, which start from the lungs, transport blood to the left atrium of heart. Pulmonary veins from the lung to the left atrium. What is the type of blood? Oxygenated. Sure. Oxygenated blood. Superior vena cava, which collects the vein from the organs above the heart, and inferior vena cava, collecting blood to the right atrium. What is the type of blood? Deoxygenated. Deoxygenated. Okay. Fine. Arteries, veins, and capillaries. So you could have seen such diagrams again. We have blue color and red color, veins move on. So as we said earlier, usually the oxygenated blood is what we denote by red color, and that is carried out by arteries from heart to other organs. And veins carry deoxygenated blood from other organs back to heart. This is what the general concept is. But only one place it was changing, and that is this place, from the heart to lung. Right? From heart to lung, it is artery. But what is the type of blood? Deoxygenated, so it is blue color. Lung back to heart, it is oxygenated, so it should be red color. But back to heart, that should be not an artery, it should be a vein. So that is the only change. Otherwise, all goes the same. And how it works on basically, there are two types of blood vessels, and additionally one. What is the first one? Artery. Arteries are the blood vessels carrying blood from heart to other organs. Correct, right? Heart back to other organs. Heart back to other organs. And veins are what carrying out blood from other organs to heart. And what is this capillary? Capillary means capillaries are the tiny blood vessels. Okay. Whenever blood is carried towards the organs, okay, let me take this as an organ. This is an organ. Right? Who provides blood? Blood is provided by artery. Okay. Now we said aorta is there. Is that aorta provides blood for every organ? Not like that. It is something like the main road. From the main road, exactly from the main road, you can't go to your home, right? Everyone's home is not located on the street. So there would be some streets. Crossroads would be there. Likewise, when the main road goes on, crossroads would be taken towards every organ. So there we give another word. By specifically their names we give. Okay. So likewise, when you come for this, now let's say an artery comes. Okay. So this artery, the main artery will be divided into arteries, again sub-arteries, and one artery will be dividing into small branches like this. Right. So these branches are called arterial. So this is an artery. And these small parts are called arterial. So when arterial is made, the thickness would be slightly reduced, because they are becoming into a very thin network so that the transmission could be done. Why do they want to do this? They want to transmit the substances. Okay. So the transmission is not directly from blood to the organs. It is something like between the blood vessel and the organ, there's a space. To that space, blood could be given what is needed. Example, let's say oxygen. Now, oxygen containing blood comes on. Oxygen would be given to that space. From that space, it would be transmitted to the organ. And if organ is supposed to give something to the space, from that intercellular spaces, that would be taken to the blood. Okay. So accordingly, artery carries oxygenated blood. Oxygen would be supplied to organ. But to supply that, if the thickness is very high, it is hard. So it has to be reduced in the thickness. So it becomes very thin. So dividing upon, it makes the arterial, and it makes thin network of capillary connected with whom? The veins. So when it is connected to the veins, like the same, there would be a branch of network. like it is connected. You can see it is coming out now at a certain organ. Now the point where they are connecting, this is called the capillary network. And the small branches of the veins, these are called venules. And all the venules collectively giving you the vein. And the sub-veins are connecting into the major two veins. Major two veins. Sub-veins should be connected. Right? So likewise, every organ does have this structure surrounding. Okay. So accordingly, from this capillary network, only the transmission is given. So imagine I'm taking something like this. Now this is the artery, this is the vein. Arterioles are given, venules are given, both of them are connected. Now when they are connecting like this around an organ, imagine this is the organ, it's connected. So this structure, this network-like structure is what we term as the capillary network. What network? Capillary network. So remember, through the capillary network only the transmissions are done. Even in the digestive system, excretory system, respiratory system, we spoke, and remember, dense network of capillaries, highly vascularized, we say, for the absorption process to be effectively done, efficiently done. So that is this capillary network. So remember, arteries and veins are connected by capillaries. Capillaries. Is that clear? Clear about that? So let's write there. So there's a box-like structure given. So inside the box, write the topic arteries and then veins and then veins. And just below that, there's a small space, not a separate a line. There's a small space is there where you can write the third point on the table, right? So make it as a small note on your writing book. Use the two color pens. right? Fine. So you can see here, same way, arteries are carrying, making into arterioles, make the capillary beds, the capillary network, connecting into venules, veins back to heart, right? Furthermore, these are the structure given for you. You can observe. So maybe several arteries, like the main artery, that means the aorta. Several arteries it is dividing into arterial, capillary network, venules, vein, and the main vein. Example, can you remember this structure? What is that? What is that structure? What is the structure given there? Hmm? And the respiratory system will waves like structures can be end of the respiratory system. Yes, very good. Alveolar sacs, can you remember? Alveoli. Okay, so we can observe, can you remember the around the alveoli there is a highly vascularized system, capillary network is it? So surrounding the capillaries are there in order to make an effective absorption. All right. So like every organ is connected, covered by these networks, so that the transmission or else absorption or whatever the sort of exchange can be easier done. Okay. Right. So when we compare these arteries and veins, we say arteries are highly thick and highly large than the veins. Why do you think? Arteries is a thickness and elasticity is high than the veins. Why is that? You can see the thickness, right? Can you see the thickness? Here's the thickness. Why is that? Artery thickness is very high when compared with the veins. What is the reason? Why do you think? You can see it may be pulmonary artery or aortic artery, the systemic artery. What it does, they take blood directly from heart to other organs. So that cannot be done at a small, low pressure because they have to go a big, journey. When compared with the pulmonary artery, systemic artery is a long journey. But anyhow, both of them are carrying blood away from the heart, which is pumped at a high pressure. So at a high pressure, blood is pumped out by these arteries, by the heart. So arteries are carrying that at the same pressure. So to withstand this pressure, they should have a high thickness and high elastic nature so that they can stretch and they can withstand that pressure. But when you come for the veins are not being pumped directly by the heart, but they carry the blood being supplied, provided for other organs back to heart, relatively at a lower pressure. So to withstand this lower pressure, they don't want to become highly thick and highly elastic. So relative to arteries, veins are less thickness, less elastic. You understand about that? Okay. So that is also given on your tube in the next page. Could you please quickly read it? In the page number 6, I guess. Quickly read. Right. Same thing. And can you see one more thing there? The valve being opening to the heart. Like this. Imagine this thing. Right? It's like. So the blood comes on, it's getting open. The blood leaves and then it closes. Again, it can't get back. So that it would be preventing the backflow of blood. So backflow of blood will not be taken place. So there won't be a mixture. There won't be a mixing of blood, so it will be effectively done. Clear about that? All right. So we already spoke about double blood circulation. So what is double blood circulation? Circulation of blood twice through the heart while it circulates once through the entire body. Correct? So while it is circulating only once throughout the body, it goes in twice through the heart. So this is called double blood circulation. So let's write there. Circulation of blood. Circulation of blood. Twice through the heart. Twice through the heart. While it circulates. Circulation of blood twice through the heart while it circulates. Once through the entire body. Once through the entire body. It's called as double blood circulation. Called as double blood circulation. Okay. Or else another way we can say, I think that is already given there, right? Double blood circulation is the summation of pulmonary circulation and systemic circulation. Right? So what is pulmonary circulation? Pulmonary circulation is the circulation where blood flows through lungs, between the heart and lungs. Okay. And systemic circulation is the circulation where blood flows through the rest of other organs, between the heart and other organs. Okay. So that's given there, right? Okay. So where we have to write. We'll write there. So the summation of that, you can see now, systemic circulation starts up with O. It seems to be like here, but it is starting from left ventricle. So the left ventricle is the blood pump for O, systemic circulation. From here, blood is pumped, systemic circulation goes to the organs. supplying oxygen, and then taking back carbon dioxide. Comes back to right atrium. Right atrium, you can see it's being filled up by two. Okay. Okay. So in the sense actually, the right atrium is being filled up, right? So right atrium is filled up and would be passing the blood into right ventricle. From the right ventricle, again it is taken to pulmonary artery. Pulmonary artery takes towards the lungs. Lung would be purifying that, taking carbon dioxide, giving back oxygen. Oxygen will be taken to the left atrium. So this is the complete circulation. So systemic circulation plus pulmonary circulation, collectively it is called double blood circulation. Double blood circulation. Okay. All right. Just below that, there is another diagram given, right? All right. Try to fill it up. Try to fill it up. Use your pencil. At the top, you have to take the head. Either sides, you have to take your hand, right hand and left hand. Okay. So complete it. The four chambers are given, and only one box is additionally given. That is the last. At the bottom, there is one long box, right? Just above that box, just cut it on. Just shade it. Cut it means shade it. Just above the long box. The bottom, at the bottom, a long box is there. Leave it. Just above that, there is a small box. Cross it or shade it. That is not needed. Okay. Others, you have to fill it up. And try to fill up with the arteries, veins also. Name of the arteries, veins also you can need. Is that enough time? Finished? Compare with the diagram. The diagram given there, compare it with. What's up? Couldn't make it. Fine. Have a look and fill it up. Check it out if it is correct. What you have done. You want to place the blue and get some water. You write the blue and the yeah. Everything you have to know. Yeah. Wait. So there is a mistake in that diagram on your tube. In this part, I'm just pointing out, right? Can you see? If it should be the vein that carries blood from lower parts of the heart, vein, not arteries. Correct that word as well. I'm going to fill it up. 2 more minutes to complete. Right? Fine. The last part, heartbeat and the cardiac cycle that we have to take. Right? So, what is heartbeat? What is heartbeat? How is your heart beating? What is the sound? Dub dub, lub dub, lub dub, lub dub, lub dub. Okay. So lub dub, lub dub. Lub sound is bit longer than the dub sound, right? Lub sound is bit longer than the dub sound. So lub dub, right? So this lub dub sound is given because of what? What do you think? What do you think? When we are opening a gate or a door, would it be giving a sound? Relatively less. Same thing when it is closed. Somewhat automated sliding doors have been reduced the sound because of the rubber pads being connected. Otherwise, gives a sound, right? When it is closed. So here there are valves that we are supposed to be closed. Tricuspid, bicuspid, semilunar valves. So these valves, when they are closed, there would be a sound given. This sound is what recorded as lub sound and dub sound. Okay. So when you come to heartbeat means heart we said it can contract and relax, contract and dilate. So what happens to right atrium, left atrium? Now we learned, it's like a two-way path, right? It goes like and comes back again. It's filling up, going. That is the way we learn. That is a process. But ideologically, what is happening here, right? Parallel. At the same time, both of the parts, both of the atrium are contracted. Both the atrium contract, both the atrium once filled up with the blood, deoxygenated in right side, oxygenated in left side. Once it is filled up, both of them will be contracted. When both of them are contracted, okay, blood flows down to ventricle. Blood flows down to ventricle. Is that clear? So this is called atrial contraction. What contraction? Atrial contraction, or else auricle. Atrium, auricle, both same. So auricle contraction, atrial contraction. So once the atrial contraction is done, here the blood goes down. After the blood has gone down, these gates should be closed, right? The valve should be closed, right? So the closing of these tricuspid and bicuspid valves are giving you the lub sound. And it takes some time, relatively longer. After right ventricle, left ventricle, both of them are filled up with the blood now. Deoxygenated and oxygenated both sides. Once they are filled up with the blood, they would be contracted. So now when these are contracting, atrium would be relaxing. Why? Already they have contracted, right? Now they are relaxing. When they are relaxing, these two are contracted. Ventricles are contracted. So this is called ventricular contraction. When the ventricles are contracted, arteries are getting the blood. Once the artery is getting blood to be carried out, now the valves are there, should be closed. So these semilunar valves, when they are closing, it will be giving a dub sound. So now, after it would be relaxed. After this atrial contraction and ventricular contraction, now continuously they won't be contracting. They need a specific time to relax, right? So both the atrium and the ventricles would be relaxing for some time. This relaxing time is called intervene. Okay. So accordingly, contraction, relaxing for some time. Contracting, relaxing. Okay. So this relaxing time is called intervening. So accordingly, there are three stages. That three stages how to take under the cardiac cycle. So accordingly, what is heartbeat rate? Heartbeat, the contractions and dilation of heart muscles, it is known as heartbeat. Sorry, let's write that. Contractions and dilations of heart muscles are known as heartbeat. Atria and ventricles of heart contract to pump blood out of the heart. The heartbeat rate of a healthy person at rest is about 72 times. So usually we say pulse rate. Then what is the similarity between this? What we get as the heartbeat will be the same pulse rate. And that is how here we measure, because it's very easy. Not only here, wherever we keep our body, finally when we are observing the heartbeat, due parallel to the heartbeat, there will be pulse passing. That means a flow of blood. How many rates would be there? It is something like, when you take for 1 minute, that means 60 seconds. It is not even 1 second for one complete heartbeat, less than 1 second. And that is why 72 times it beats. In a healthy adult person, it goes 72 times per minute. 60 seconds, 72. And the pulse rate will be also the same. Pulse rate is also similar to heartbeat rate. And when you are in an emergency condition, when you are scared, when you are getting into, some sort of tense condition, stressed out condition, this heartbeat rate may increase. Okay, and low pressure time it may decrease. So there are fluctuations. Randomly it may happen, but rapidly, continuously, frequently when it is happening, that is not good. You have to consult. You have to consult. Okay, and when you count this now, adult healthy person 72. Does it mean that smaller kids are less than that? No. Actual thing is infants when you are taking. Once the babies are being born within the very first several months and all, you just keep on. You can feel the heartbeat rate is very high. Now it is not abnormal. So if a person learned only this, okay, they think that something different in that they get scared. That's normal because they're just growing up. They need more biological processes to be completed, and not the complex ones, but they're growing up. But abnormal, if it is high, it's a problem. Somewhat it goes about 80 times. 72, no? 80, 85, it may. But more than that, 90, 100, if it goes on, that's a problem. Is it clear? So that is hard, right? So you see, pulse rate is also similar to heartbeat rate. The love sound occurs when both tricuspid and bicuspid valves are closed during the atrial contraction. Once the atrial contraction is done. And the dub sound occurs when the semilunar valves are closed during the ventricular contraction. Lub sound is longer than dub sound. Underline that. It comes in MCQs. Lub sound is longer than dub sound. So first lub and then dub. This could be observed through stethoscopes. So stethoscopes they are using in order to measure this, right? Record this. Right. Now, from one heartbeat to another heartbeat, again, starting of one heartbeat to the starting of another, or ending of one heartbeat to the ending of another. That means starting point to starting point, one cycle. So this is called cardiac cycle. So cardiac cycle refers to a complete heartbeat from its generation to the beginning of the next. That means generation of the next. Starting of one to the starting of the very next. Very next. So this complete process is called cardiac cycle. In one heartbeat, atria contract and then ventricle contract and both of them relax. So atria contract, ventricles dilate. Next, ventricles contract, atria dilate. Atria dilate. Contraction of atria is known as diastole. So how do we name the atrial contraction? Diastole. So this diastole it takes about just 0.1 second time. 0.1 second time. Quickly it would be squeezing. Whereas the contraction of ventricles is known as systole. It takes about 0.3. So these are approximated time. 0.3 seconds time. That is for ventricular contraction. After that, atria and ventricles are in relaxing mode, and this is known as intervene. So diastole, systole, intervene. Diastole about 0.1 seconds, systole is about 0.3, and this goes about 0.4 seconds. So approximately 0.7 to 0.8 seconds. 0.7 to 0.8 seconds are taken for one complete cardiac cycle. That means less than 1 second. That is why 72 times per minute. Accordingly, 0.7 to 0.8 seconds are taken for a heartbeat of a healthy adult person. Clear about that, right? So let's write that cardiac cycle. Heartbeat already we wrote, right? Right? There are three stages. What are the three stages? Diastole, atrial contraction, systole, ventricular contraction, and intervening atrial ventricular relaxation. Right. So here, atrium, both the atrias are contracting, blood goes in. So I said the cuspid valves are opened up in order to allow the blood to flow. After that, they close. That gives you the lub sound, both of them together. And ventricular contraction, when the ventricles are contracting, okay, the both the blood are sent to arteries, one from the left ventricle to the aorta, right ventricle to the pulmonary artery. Once that blood is sent on these semilunar valves, okay, the aortic semilunar valve and the pulmonary semilunar valve, they would be closing. That the closing sound together would be giving you the dub sound. Dub sound. So this is how continuously dub sound is heard, and it goes about 72 per minute. 72 per minute. And this lub dub sound, or else the cardiac cycle, the heartbeat can be diagnosed, can be screened on in a diagram. We take it as a computerized stuff. Actually, it is called the ECG, electrocardiogram. So what actually given by ECG? It denotes the potential changes while the heart is beating, while the heart is functioning. What is the potential change happening in the cardiac muscle tissue? So this is what denoted by this electrocardiogram, right? So see, this is used to get information about the heart function. This tracing denote the potential changes take place in cardiac muscle cells during heart function, right? Remember, this should be asking the questions. They ask you, what is denoted by ECG patterns? It denotes the potential changes happening during in the cardiac cells while it is functioning, while the muscles are functioning, the heart functioning is carried out, right? So what actually it represents the same three stages: atrial contraction diastoles, ventricular contraction systole, and intervening the relaxing mood. So you can see here, what are the three stages? It goes like, it's a curve, it's a half curve, right? Let me take it smaller because the other one is bit larger. This is first. This is the letter P. That means atrial contraction. And then what happens? You have to take it down and you have to send it up again furthermore down, right? And then it comes to the same level. So it goes like, this is the point Q, R, and S. So that is QR is ventricular contraction. And then again, on the same line it goes, giving relatively a larger one when compared with this. Okay, and this is T. T is the intervene. All right. So this is what the usual ECG pattern if a healthy adult person is trained on. So looking at the ECG, they can say if the person has got any sort of heart attacks or heart failures or any sort of maybe pressure difference or whatever related to heart, any disorders are there. That could be diagnosed looking at this because it goes abnormal. It goes deviated from the proper pattern, right? So if the pattern is changed according to the pattern, where it is changing, how it is changing, so that is how they diagnose what is the problem in the heart. Okay, and if there is a problem in heart, what is the reason for that also could be diagnosed. Some of the ideas they can obtain, right? So ECG wave patterns deviate from normal patterns due to dysfunction of heart. All right, and now related to this, the blood pressure is also experimented. So the blood pressure we take, there are two types of blood pressure. That is not the high blood pressure and low blood pressure. So this blood pressure is depending on the place, okay, and the occasion. Systolic blood pressure. This is created during the heartbeats. During heartbeats, when it contracts and pushes blood through arteries. So when the blood is pushed to the artery, there is a pressure created because of the pressure given by the heart only, blood is pushed into arteries. So once it is pushing the blood into artery, what is the pressure retaining? That pressure is called systolic blood pressure. What blood pressure it is? Systolic blood pressure. Okay, blood once it is sent to the arteries, what is the blood pressure? And this is usually 110 to 120 millimeter HT. HT means mercury. So mercury millimeters. So mercury millimeters 110 to 120, that is the normal, right? Diastolic blood pressure. Now, when the heart is resting between heartbeat, after the ventricular contraction, that would be resting, right? During the resting period, what is the blood pressure? During the resting period, during the intervening time, what is the pressure inside? That is called the diastolic blood pressure. So diastolic blood pressure, the pressure in the arteries when the heart rests between the beats is called diastolic blood pressure. So that is about 70 to 80 mercury millimeters. Mercury millimeters. So how do we denote it as a blood pressure of a common healthy person or else adult healthy person? How do we? That is given as both the systolic and diastolic blood pressures are taken and we are going to divide it. We are dividing systolic over diastolic. Systolic over diastolic, that is how we take the normal blood pressure or else average blood pressure. So usually it goes 120 over 8. 120 from systolic, 80 from diastolic. So usual a healthy adult blood pressure, normal blood pressure is 120 over 80. 120 over 80. And this blood pressure may be fluctuating, changing because of several reasons. Several reasons, right? So all it's there on your tube, right? Nothing in her right, correct? Yes. Blood pressure. Blood pressure is measured in millimeters mercury. Millimeters of mercury means mercury millimeters, HgMM. And the normal blood pressure is 120 over 80 millimeters mercury. Right there. Right. So what are the factors affecting the blood pressure? Aging. When we are getting age, usually the blood pressure would be fluctuating, changing, sometimes high blood pressure, sometimes low blood pressure, and it will be changing along with the diseases that we are having. With the diseases like diabetes, cholesterol, okay, those diseases will be changing the blood pressure. Sometimes the people may be fainter, and when they are starving, also that is an issue here, right? And stressful mentality, always, stressful mind with pressure, depression, and all. Maybe because of a phobia, maybe because of something is always, triggering within the mind in a negative way. Some sort of, scaries, a fear related to something like phobia. Okay, maybe because of the shadow or sound, right? Lightning. So different sort of things, or else ghost stories, right? So all these would be always, harming your mind, So accordingly, stressful mentality would be also affecting. And the sixth, the gender. Men to women also there is. Men to women also usually there is. So whom do you think there would be high blood pressure? Men or women? Whom do you think? Women. Whom do you think the blood pressure would be high? Usually, normal adult people when you are taking women, men. What do you people say? Yes. Is it men or women having high blood pressure usually? That means that's not continuously high blood pressure, always getting into high blood pressure. Whom? Probably everyone would be saying women. Right? Whom do you think? Men. Men. Right? That is because of, okay, now you might be arguing with me, right? So that is because of they do have different biological structures and they do have different physical, mental stabilities. Okay. So men have to go for work, not only just going 8 to 5 or whatever, or different sort of criteria, but a responsibility over the family. Okay. Responsibility over the family to feed them, to protect them, to provide everything what they need, and also going out of home, they have to think about what's happening at home. Are they protected? If the kids are going to school, are they protected? Are they safe? So those stuff should be there within the mind. Meanwhile, if he is an employee, if he is a labor, he has to think about the company sides also, because that pressure would be also there. On time, it should be finished up. And some people are there while they go to work, they have to drop their kids. Between the lunchtime, they have to come back, and again they have to go. So different sort of things. I'm not saying women are not like. They have to take on the works at home, morning to night, everything they have. They have to. But the only thing is the environment. The environment is the same. They don't expose for external environments most, unless they go. Yeah, I'm coming to the point. Wait. I'm coming to the point. All right. So usual, ladies, and we are taking now. Okay. So internal environment, and always with someone. Someone's face should be there, which is within the family. There won't be any external exposures forcing them. Let's say if the ladies are going for work, okay, going to work. So they are also going to work. I'm not speaking about the, what you call, female running families. That's different. That's different. That means maybe because of no males are there. No brothers. Oh, brothers are not looking after. Oh, no father. Okay. Oh, father might be at home, not at home. Okay. So, or else he might be working somewhere. So something else. Okay. Helpless without a male. So you see, helpless without a male. So the male's pressure should be taken over the female. You understand that? That means if there is a male, that pressure won't be there on the female. That is a usual. So that doesn't mean that it is a masculine birth. Both the parties are equal. Both the parties are equal. They do have different works. Okay. But what I mean here is, understand properly, what I mean here is, physically, the mentality they have got. Either they are going, let's say the girls today, the young girls today, they are going for work. They are going for work most of the time, some of them, okay, some of them, to look after themselves, to earn for themselves, to save for themselves, for their future. Few of them for fun. Yes, you don't believe? Not a single boy goes for work for, right? Okay, they might be having fun separate, not going for work, because they can't work for fun. That the person would be, chasing, but that won't be happening for the females as well. Okay, and some women are there. Okay, relatively, they have to take care of their kids. They have to take care of the family. There are people. So when comparing the ratios, that's a big leap. So commonly only I'm speaking about, right? So relative to that common strategy, now modern world is going up with both the parties are equal, right? Both the parties are equal. Okay, but the thing is, mental stability when we are taking up with, okay, mental stability when we are taking up with a women when you take, okay, unless if she is a well matured and a well, what you call, patient. If she doesn't have those qualities, she quickly gets stressed out. Then the pressure rises up. It is something like, you have seen, I don't know the name, I can't remember the name. Hit ball or something like that. When they are hitting on, quickly it rises up. There's a game. Okay. So that is to express out, that is to denote what is the muscle strength. Once you hit on using a hammer, once you hit on that bottom, it goes up. Depending on your strength, it goes. So like that, okay, quickly it rises. Quickly rises. And quickly it would be released out. Whomsoever is there would be released out. And again, like the gas gone out, comes back. Men is not like that. Keeps on. I'm not, making it something like, no, it's a reality. Okay, mentality. Something like keeps on everything. Look at your father. If I'm saying wrong, you can understand it. Look at your father. Okay, you may think, no, my father is not like that. He will always shouting. Maybe because of too much stress. The stress would be released out upon shouting. That is one. But I'm not saying that is a positive way. There are many other positive ways. Okay. And moreover, with all these pressure, when the father or someone, the male goes to home, the pressure given by the spouse, the pressure given by the mother, it furthermore increases, right? So imagine how that person, bears everything without speaking a word. When the mother shouts at, father keeps quiet. Why? He knows if he goes arguing, it increases further. It won't stop. It never ends. It never ends until the next day. Better quiet. Be quiet, listening like you would be doing something else. Probably what happens is, okay, probably what happens, he seems to be like he pretends to be listening, but he might be thinking something else. He might be calculating something else. That is how they come out of that problem. Keep on arguing, it goes beyond the level. So ultimately, this goes up with males. Okay. Instead of, except some cases, as I said now, some of the examples, otherwise it is common. Okay? That is held by females also, female also, right? And the diseases are common for everyone. And why I spoke about this basically here, because most of the time we say everything related with heart basically. Heart is not anything other than a blood pump. Now, different sort of things you are saying. So related straight away, directly, it is related with affection. It is related with love. So they say heart, I'm giving you, I'm in love with you. They are saying, right? You are not small, you are hearing of that. So you think like heart. Heart is what given. If the heart is given, the next moment the person is dead. That is why we say love is blind. Correct? Love is blind. It doesn't know. It doesn't know what it is actually. Real love is not there. Real love, when you are taking, it is divided into several categories. Parents to their kids, kids for their parents, father to mother, mother to father, so sister to brother, brother to sister. So those are also, and the neighbors and all whom you are interacting with, that is also love. Different sort of love. And this love, what you think about in the young age is totally different. It's because of, it's pushed, it's injected to your mind by the social medias. You think that is the real love. That is not the real love. Okay. And that love is not denoted by the heart. Heart is just a blood pump, not an emotional pump. No emotions stored in heart. No emotions are really connected with the heart. It is just a pumping blood structure. And where the emotions are connected with? Emotions are connected with your mind. Your mind. But the thing is, they can't show here, right? Whenever they want to show that expression of love. So heart is close by, so they take heart. Okay? But heart is just a blood pump. Then one person asked me this question when I was doing this chapter in a class. Then, sir, why do we feel something happening here during love or what they are? It's an experience, fine. Okay. So it is actually, right? That is because of, when we are doing something, when the, what do you call, happiness increases. Okay. Any sort of things happily, positively, when it is increasing, our circulation increases. Increasing the workload or machineries. So that is what we feel. Is that clear? Right. So accordingly, so this is related to the heart and heart related activities and all. So another system is connected, interconnected, that we'll be taking in the next class. Okay. So that is the lymphatic system. So please read and come. There are new words there. Okay. So we'll end up with this. Okay. Fine. To take that, I'll give the next week. I'll give the. Oh, no questions, right? Yeah, no revision today. We'll switch back with the revision classes from next week. Okay. Right. So